Hello everyone, System Chalk here with, I'll call this section 6.2, part 6.2. So this is the week 4 of Roguelike. Our Roguelike Dev does the complete Roguelike tutorial. There was a large amount of refactoring. I think that probably took us about a half hour in the previous episode. And then there's part of part 6, which obviously we're still only about halfway for. I actually have too many books on my desk here, so they're covering up the last little bottom of the screen. It's hard to see the full bar, but it looks a bit like we're about halfway through. Excuse me. But yeah, I kind of left it. I was both quite chatty and the video was getting a bit long, so I figured I'd split these things up. In an ideal world, I will do the remainder of part 6 and part 7 in one go. If it takes too long, so be it. But obviously there's a lot going on in this, and I don't have too many sort of big questions. The main questions that I have are sort of related to the, excuse me. I think the big questions are really more related to some of the basics in terms of, getting an ideal VS Code set up for myself and understanding the type hinting in Python a little bit better. But that sort of stuff is stuff I can do on my own time. There are maybe on a deeper level, I think I probably could spend some time sitting down and thinking about this idea of sort of, what was it? Engines having, I don't even remember what it was. It was something like engines having game maps that had engines. And I'll put it to you this way. I don't think it's wrong. In fact, I think there's most things in this tutorial. If I think something isn't working, or if I think something doesn't quite make sense, that is more of an indicator that I have missed something or that I'm having difficulty understanding, rather than it being a, okay, I found a mistake or something like that. But it is important to make sure that things like that don't just go unnoticed or unaddressed. I think it's important to note that when I look at something like that map and I say, it's like, okay, so, I go into the map, we're looking for something that's blocking. So, why would you look anywhere but the map? And then when I get to that moment when I'm like, wait a minute, what's an engine doing in here? And like, why is it natural for me to pull this out? It's a really good example of where the way that we've chosen to represent these ideas, this world, if you will, in terms of data, specifically data that can be processed by Python and its libraries, third-party libraries in some cases, but Python and its libraries all the same. That to me should be a really big signal that there may be room for improvement, or at the very least room for better understanding on my part. Because as I sort of said at the very end, the ideal is not for us to sit down and think entirely in a world of, 3 integers between 0 and 255 for colors. I want to be thinking of the world in terms of, black and white is, I suppose, represented in this, but, all of the different shades in between, this sort of yellow and bluish color in terms of representing different fields of view. Obviously, I want to be thinking of this idea of somebody moving throughout a dungeon lit by something that doesn't give a complete image, right? We don't have a GPS of the dungeon. We have torchlight. And maybe there'd even be an interesting idea of maybe memory or hazy memory, so that you don't even get to see the outline permanently. After a certain number of turns, the walls sort of start disappearing. There's lots of different ways that you can play around with that. And it is much more interesting, to me at least, to be thinking on that level of, tangible objects, or I mean intangible in the case of a video game. It's obviously a digital creation. But, to be thinking about these experiences and to be thinking about these ideas as something that a player is going to interact with. And of course, hopefully that player is me. It would be a great shame to spend all this time working on something that I don't enjoy playing. But in order to get to that level, I do need to have sort of data structures to support all of that. And this is why, again, I don't want to make a really big deal out of it. And like I said, this is probably just a question in terms of me having a better understanding in terms of this project. But that is an important thing to note, right? You don't just sit and say, it'll work itself out. Or, maybe if I just stare at this tutorial long enough, it'll work. Either you should be able, in my view, you should be able to defend the choice and say, even something like, look, this isn't an ideal solution, but here are the other ways in which this representation creates even more problems, right? Something of a tragic view of software. But I mean, I think all of us have been in jobs where we make compromises like that in order to achieve sort of the higher goal of getting the work done. Or alternatively, if you disagree with it, what you would want to do is bring yourself up to a level where you improve. You're able to build on that. First of all, I actually don't know what the license for this tutorial is, but I'm assuming it's not. I'm assuming it is some kind of open source or Creative Commons. I'm assuming that people can use this and build on it for their own games. At the very least, you can take the concepts that are introduced in this and create your own works. And I think, the hope would be that if you are not at a point where you can say, okay, here is a better representation and this is what allows me to create something better, at the very least, you sort of I shouldn't say you, this is really about me. I ideally would like to be at a point where I can sort of just say, it's like, this is the trade-off that is, that is being expressed here. I don't necessarily agree with it, but I'm also not willing to take on all of that extra work to improve it in another way. And that's completely fine, right? Like there's a lot of, the analogy here that I would like to draw would be how I feel about some short stories. So I've actually been reading one which I quite liked when I first read it, and I still like it. But I actually don't think it is as good as it was when I first read it. And one of the reasons why I feel this way is I've been trying to learn how to write short stories. It's a different beast than longer form, and I'm sure you've all figured out that, excuse me, brevity is not my strong suit. But I sort of tried to pick this thing apart, and some basic things, right? So I tend to be a bit metrics driven. So how many words does this have? How do I break up the story into sort of different scenes or different parts? How long do they spend on each part? What does it serve in terms of this overall understanding? And what I found interesting was there was this, it's a science fiction story, so I was very much interested in the very big ideas. But by looking at the story, there were actually small things about individual relationships with characters, particularly the main character and their brother, that I never really noticed before. It's not that they weren't, I think to a certain extent you can't read that story and not sort of understand a bit of a dynamic of the brother, but I maybe didn't appreciate as much how much that informs the structure of the story and the specific way in which the events happen. I think you can tell that same story with a different relationship between the brothers and everything turns out the same way. But there is a bit more going on than I maybe appreciated at the time. And through that process of sort of picking it apart and sort of seeing how it worked, I gained a better understanding of that story. And even if in that particular case, it was like, you know what, I think there are other things that this author has done that I think are better. That is still valuable, right? Because in the end, if I do wind up making short stories, my ability to show that kind of discernment, my ability to think critically, and critically doesn't have to mean, negatively, but to be able to think in specific terms about the types of media I'm exposed to try and think about how it works, maybe how it can be improved or how it might have worked differently. In the end, that would hopefully be something that makes me a better creator when I sort of take up my own pen or take up my own IDE. So in a similar sense, right, the hope here would be if I encounter something in this tutorial and I say, all right, it doesn't really seem to make sense to me that the engine is inside of this. And it's like, I understand that it works, and I understand that this this is a sensible way from a better programmer than me thinking carefully about this project. in the end, what I kind of want to do as that second layer is to say, all right, if I was put in the same circumstances, knowing what I know now, would I make the same decision? Or is there a decision that I could make that would allow me to think more naturally about the problems that I'm encountering? Because again, nobody's going to sit down and play any roguelike and say, oh, the way they represented the game engine and the maps in data, this is really elegant. You can see the passion behind this project. No, the only people who are ever going to say that are people who can see the source. And even then, they may be interested in other things, right? So map generation, for instance, would be a big one. But to be able to know that for yourself and to knowing that that is a tool through which you're going to be able to create experiences, to me, that's where the emphasis lies. Anyways, I kind of repeated myself a couple of times and we're 10 minutes in. So let's get to work on our entity factory. So with all that in place, we'll need to refactor our entitiesfactory.py file in order to make use of the new actor class as well as its components. Modify entity factories to look like this. So first of all, we're jettisoning the entity, although I guess we can just still take the actor out of that. And then we're adding the components as well. Nope. Okay. So our player is no longer an entity, it's an actor. And we'll split this out the way that they've got it in the code. So character, color, name. Need to give it an AI. I'm assuming that's AI class. Now this is interesting. So why are we saying this is a hostile enemy when it's the player? And we don't have blocks movement anymore. This is one of these cases, probably like the value that, determines how the cost of being a blocked entity, and so the sort of thing that we'll call it the crowding parameter. For the same reason that would probably be better to hold that as a variable in some sort of a file, I have to imagine that the player HP, defense, and power would be something that you'd probably want to keep in a separate file. I think they said later that there's going to be some JSON file or something like that they store all of this in. Because you can sort of imagine, I've been talking a lot. I think the reason I've been talking about this a lot is just because this is the point in part 6, particularly with the refactoring. You're really sort of thinking of this as a way of thinking, basically, or tools for thinking, maybe is the better way to put it. You can imagine how you have a very gifted designer who does not want to think in code. Or perhaps an even more, maybe another situation where you have somebody who's a very talented designer, but they are not familiar with the language or the tools that you are working on, right? So I imagine that this would probably happen, let's say, in a case where Rust, which is a very, I don't know if I should say very popular, but definitely it is a language that seems to have a very large number of passionate adherents, and I think there is a certain amount of buzz around it, which leads people to want to try it out. So you can sort of see, particularly in a project that's maybe not done commercially but done for people's interest, how using tools that people find exciting or they want to get some experience in would be a good idea. So let's imagine now that you have somebody who is quite a talented designer, but they are not familiar with Rust. And either they're not interested in learning Rust, or maybe just there's simply not enough time, and that taking the time to make this person a Rust expert would be too much of a drag on the project to really get the other parts delivered as you want. Well, it would be quite sensible to make it so that you have the people who are excited about Rust building all of these things that are very helpful. And in the case of Rust, chances are you're doing it because you want to have high performance. Maybe you'll have, all sorts of threads running around, and one will do a weather system and one will do, terrain generation based on some, some actions that a player takes or something like that. And sorry, I'm obviously showing my lack of creativity here as usual, but whatever it is, you have all sorts of different things that you can do. And the last thing that you would want to do is to take that excitement of the technology and produce something that is just not as fun to play because you let the you kind of left one of the members of the team behind. And so as a result, being able to say, okay, instead of going through and trying to figure out which of these files contain the values for the player character as opposed to the troll or the orc or something like that, you can sort of imagine that keeping that in a separate file with very clear names or at the very least some descriptions, that allows someone to make the changes and see how they work without having to sort of phone up the programmer and say, hey, can you change it from 30 to 29 and send me a build? You can do that yourself. You can do that tuning. And then, of course, if there's something a little more structural, that's when you bring in someone else. And from what I understand, I think this was also in ye old days. I think this was also something that people did to avoid having to recompile everything. So I think there in at least some of the old games, I imagine this has to still be true today, but it used to be that there would be sort of a file that would have a whole bunch of different values, which would be the sort of thing you'd maybe want to change while balancing or building up a game. And this would be something that was read in when the game started. And this is essentially to avoid having to compile, StarCraft again or something like that. So again, I'm sort of getting all of this secondhand, but I can see a couple reasons why you'd want to structure it that way. All right, so we're also turning the orc and the troll into actors. So we're going to do the same trick here, and we need to make sure that we add the AI class. So I noticed just on the rough note, it isn't complaining that we didn't load in the entity. And I don't think importing actor solves that. This should be fighter. Yep. So I think it's always valuable to just take a look at, oh, that's interesting. Right, because we didn't define them. I think it's always worth kind of looking at these sort of things, right? So what do we know about orcs? Well, we know that they have a third of the health of the player, that effectively, or no, sorry. So if you look at a player, right, if a player hits a player, presumably the attack does 3 damage, which is the same as what the orc does, but the player can hit for 5. So essentially 2 hits will take down an orc, and if the defense reduces the power, then essentially it takes 30 hits from an orc. But of course, there's multiple orcs on a level. So you could sort of think, well, if everybody kind of gets one whack at a time, if it takes 30 hits to take down a player from orcs, and it takes 2 strikes from a player to take out an orc, that effectively means that you can have 15 orcs on a level before the player sort of succumbs to their wounds. Obviously, there's a lot of this depends on sort of when certain attacks happen and whether or not the player gets surrounded or something like that. But that's just a rough idea. And what we might want to do is sort of say, okay, realistically, how many levels do we have? How many what is our limit in terms of the number of enemies that we put in? And then, of course, we have the troll, so that's going to play around with the numbers a bit too. So you don't block movement, but you do have an AI, and you are a hostile enemy. Or sorry, you are a fighter. Okay, and this is still interesting, right? So in this case here, 1 extra power. So in this case, a troll effectively with the player's default defense, This means they get 15 different strikes before they can take down a player. They have a defense 1, which basically means that the player will need 4 strikes to take down a troll. And from there, you can work out. And then, of course, what you'll do is you'll just sort of work out the averages. This one's fairly easy because we know that I think it's 20% of the enemies will be trolls. So essentially what you can do is just sort of work out a range of enemies based on the number of rooms that you expect to have in the area. Take some averages and see, do we think that the player has sort of a fighting chance to be able to get past this? And then perhaps what you might do is you might decide the distribution on potions would, healing potions you would probably want to sort of calibrate the availability of potions accordingly. We've changed each entry to make use of the actor class and use the hostile enemy AI class for or control types. The player doesn't use the AI, so the AI given to it doesn't matter other than an AI must be specified for all actors. We've also defined the fighter component for each, giving a few different values to make the troll stronger than the orcs. Feel free to modify these values to your liking. How do enemies actually take their turns, though? It's actually pretty simple. Rather than printing the message we were before, we just checked if the entity has an AI, and if it does, we call the perform method from the AI component. Modify engine.py to do this. So I think we need to open that up. Handle enemy turns. Right. So yeah, we'll just remove the print line entirely. Entity has an AI. Entity AI. Oops. Perform. There we go. But wait, game map actors isn't defined. What should it do, though? Same thing as game map entities, except that it should return only the actor entities. Oh, did I do that right? No. So let's change that. So for entity in set, self, game map, actors. Nope. Okay, so add the method on game map. All right, we need, we have iterable. All right, what do we have here? Iterable, optional, and type checking. We need iterable iterator. And nothing to change in type checking. So now we need to add the property for def actors. Or sorry, property for actors. So that returns an iterator of actors. Apparently it doesn't let me tab complete that. And you can know because of the yield that we have a generator here, which for entity okay, so self entities, remembering that self is a game map. Take the entities from the game map. Each entity in the entities is called an entity. If that entity is an actor, and if that entity is alive, yield each actor. And then we add space. Oh. There we go. And then get actor at location. I don't know why I keep, it's just force of habit. I don't know why I think it will autocomplete a function name that, I guess this would be a method. I don't know why I keep thinking that it can tab complete something that doesn't exist yet. Okay. So get actor at location, essentially what it does here is that we take all of the actors, which we've got here. It's yielding the actors that are actors. If you are in the X and Y position, so this would be interesting. Now, these are already blocking, so presumably there is not a situation in which there is more than one actor on a space. But essentially, if you have X and Y coordinates that match what was passed to get actor at a location, you return the actor. And I think in this case here, so let's say that we have 10 trillion actors and you're the second item, that will run faster than if you're at the end of that list, because it's going to return as soon as it finds something that matches the X and Y. I imagine, well, I'm curious about this actually. So I know there are different data structures here. So I don't know if in some games, if they would use some kind of, I guess like a dictionary to access certain enemies, because then you would, well, I mean, I guess if you indexed them by their X and Y position, but that strikes me as probably not a very effective way. Would you really be updating your index each time? I've only ever seen them put in as arrays. So yeah, presumably in this case here, this is the same as putting them inside of an array. Be an interesting question though to say. I do wonder if there's any discussion in terms of the different ways that you store enemies. Okay, our actors property will return all the actor entities in the map, but only those that are currently alive. We've also went ahead and added a get actor at location, which, as the name implies, acts similarly to get blocking entity at location, but only returns an actor. This will come in handy later on. Run the project now, and the enemies should chase you around. They can't really attack yet, but we're getting there. So this seems like a great time to make sure that I haven't put anything too ridiculous in the project. Okay, nothing. Oh, there we go. The actor object has no attribute is alive. So let me just make sure that is alive. Okay, yep, so just wanted to save this before I do anything else. Yep, nope, doesn't like that. Okay. So I'm going to assume that this game, or that the tutorial is correct and that I've made some sort of an error somewhere in here. So let's take a look and see what is alive looks like. Yep, that was in init. So not the first time I've made that mistake. Hopefully the last, but okay, this is promising. Oh, engine is not defined in ai.py. Presumably it is the self. So as you can sort of see, Python, one thing I do very much enjoy about Python, and I'm not in a position to really like do that much of a comparison between programming languages, but among the ones that I have used, I really do like how it feels like you have a fighting chance with most of the errors that you get from Python. I've definitely used more than Python, but by far Python has been the most helpful in terms of just finding what I need. So this was on line 35. So this is in get path to so here's get path 2. We're looking for entity in self entity game map entities. If the entity blocks movement and the cost is this, then the cost for entity X and engine, there we go, entity. All right, we are running for our lives from 2 trolls. Oh, you kick the player, much to its annoyance. They're pummeling me. All right, so this would be where we... Oh, but the orc is going to block my path now. Yep. Unwinnable game. Let's try that one more time. I did want to try and check out a hole. Okay, troll's going to be chasing me. Oop. Let's send them on a merry chase. This is actually kind of an amusing little, ooh. This is an amusing little challenge on its own to try and, complete the level without getting caught by the swarm. Obviously, we'd be dead if we were playing this for real, but... Okay, trying to get a little bit of breathing space. Uh-oh. Well, we did our best. I think that's a good enough test to say that everything is working the way that it should. So... Okay, that's not right. Well, we're not there yet. I'm sure it's right. Get actor at location. Okay, run the project now and the enemies should chase you around. They can't really attack you yet, but we're getting there. All right. One thing you may have noticed is that we are letting our enemies move and attack in diagonal directions, but our player can only move in the 4 cardinal directions, up, down, left, and right. We can fix that by adjusting inputhandlers.py. While we're at it, we may want to define a more flexible way of defining the movement keys rather than the if-elif structure that we've used so far. While that does work, it does get a bit clunky after more than a few options. We can fix this by modifying input handlers to, we can fix this by modifying input handlers like this. All right, this will be interesting. Oh, that is kind of neat. Okay, let's make the adjustment. I am going to switch. I know we had the cases, but that was, I do want to follow this a little more closely. I think this makes sense. Action, bump action, escape action, wait action. Okay, so after type checking, we define a big dictionary, move keys. I notice it's all capitals, which presumably is indicating that it's a constant. So tcod event dot. So what I'm going to do here is just copy this. I know copying is a recipe for sadness, but I'd rather do that. Actually, I could probably just copy this whole part. The temptation, of course, is to just copy and paste this this whole dictionary. But the thing is that the author of the tutorial needed to write this. And I did say at the start that I wasn't going to copy and paste. I wasn't going to take shortcuts. So I am kind of, I mean, this isn't necessarily all that much better than copying and pasting, because I haven't been thinking in my head, okay, 1, 1, 0, 1, so on and so forth. I'm just kind of, I'm just kind of going through the motions here, but. All right, there's no 5. I was wondering why there was that red squiggly there. Okay, I've got 8 is 0 and minus 1, 9. I'm going to take a second here and make sure. So we've got 1, 2, 3, 4, 6, 7, 8, 9. Presumably 5 is a weight at some point. I shouldn't complain about the VI keys because they are, I believe those were the original controls for Rogue, but I feel like I guess it's Vim is like a trap that get sets for me. Every time I go in there, I feel like I have to do some kind of search for how do I get out of Vim. Okay, so that's the move keys spoken for. Actually, I think this counts as a set rather than a dictionary in this case. All right, so what we do here, instead of the, actually, hang on. Yes, there is the up, down, left, left, right. Oh yeah, sorry. Now I know what's going on here. There's the diagonals added as well. I completely spaced out on those. So we can get rid of even the match. Let me just double check that. Yep, no, that's good. So again, this is the tuple getting unpacked. This is us. I don't think we've got a dictionary yet, but the square bracket here, same as using the index, we're pulling something out of that dictionary. And I think it's called a hash table if you don't normally do Python. Okay, nice and small. Not quite sure why there's 3 little dots down here, because this to me is the end of the file, but we can always compare that to the main. We can always compare that to the main or the program at the bottom if we are worried about that. The move keys dictionary holds various different possibilities for movement. Some roguelikes utilize the numpad for movement. Some use V keys. Excuse me. Just had dinner before I started this. Ours will actually use both for the time being. Feel free to change the key scheme if you're not a fan of it. Where we used to do if-else-if statements for each direction, we can now just check if our key was part of move keys. And if it was, we return the dx and dy values from the dictionary. This is a lot simpler and cleaner than our previous format. So now that our enemies can chase us down, it's time to make them do some real damage. Open up actions.py. Looks like we already had that open. So we're adding and removing. Nope, actually just adding. So adding actor from entity. Under the action class, we are changing entity to an actor. That's just a type hint. I don't think we change anything inside. And likewise inside of action with direction, we are now an actor. Finally, we do after blocking entity, but before perform. And again, the splat gives us the coordinates that we need. Okay, so target actor, self, engine, game map, get actor at location, splat, self, not comma, self dot, dest xy. Okay, excuse me. There needs to be a condition under which the target actor gets called. So for melee action, so the target is now target actor. All right, and we're replacing the text with real damage now. So when I take a look at something like this, damage, self-entity, fighter power minus target fighter defense, I almost imagine at this point that there would be some sort of method or something to damage a fighter. I wonder if that's going to be changed at some point. I don't know if ever... I think I talked about this before, but the F is for format, so that we can say what the what's attacking us. Wasn't HP an underscore value? Right, but then it had property to make that. Okay. Okay, so we're actually increasing the amount of text that we'll be seeing rather than decreasing. And then bump action, we change to a target actor. The actual actions themselves remain the same. We're replacing the type hint for entity and action with direct and action with direction with actor instead of entity, since only actors should be taking actions. We've also added the target actor property to action with direction, which gives us the actor at the destination we're moving to if there is one. We utilize that property instead of blocking entity in both bump action and melee action. Lastly, we modify melee action to actually do an attack instead of just printing a message. We calculate the damage, attacker's power minus defender's defense, and assign a description to the attack based on whether any damage was done or not. If the damage is greater than 0, we subtract it from the defender's HP. Actually, I guess the other thing that's interesting too is if I have a defense... Let me just double check this actually. So if I have a damage self-entity fighter power minus target fighter defense, if my defense exceeds the enemy's power, my health goes up the way this is built right now. So this is definitely a case where I think we would want some kind of method. Oh, wait a minute. No, sorry, that's wrong because if the damage is greater than 0. Still think we're going to write a method for this though. Sorry, lastly, we modify melee. Sorry, I'm feeling really sleepy. Lastly, we modify melee action to actually do the attack. Instead of just printing the message, we calculate the damage, attacker's power minus defender's defense, and assign a description to the attack based on whether damage was done or not. If the damage is greater than 0, we subtract it from the defender's HP. If you run the project now, you will see the print statements indicating that the player and the enemies are doing damage to each other, but neither side can actually die. Combat doesn't feel high stakes just yet. So let's actually run this before we go further. All right, so I'm going to want to address these future warning. Actually, you know what? Before we do any of that. Oh. Yeah, we're going to change a lot of these. Right. Okay, there's no nice way to handle this. I don't think. Well, maybe. Okay. So TCOD event keysim up. So if I could do this, let's see how far this gets me. Okay, so we've got keysim up, down. Let's actually just open this right up. So up, down, left, right, and page up, page down. So KKP should be replaced with keysim. Okay, that's all the same. KH should be keysim H. Let's make sure that we have that. Looks good. Keysim clear. Okay. Obviously, we'll get the errors if that does come up. What do we have here? Okay, self-dispatch. Func event, input handlers, line 70. If key in move keys, key is not defined. I think I forgot to actually give this thing a name. No. Right. This is where I I got a little too clever. There we go. So I need key. I think it's key. Oh God, I hate it. Event.sim. I think that's right. That's one I'm going to want to double check when we get to the end of the program. Okay, so no immediate errors, but none of my keys work. Okay. So I'm going to cheat. This is just because this text isn't available else. Actually, you know what? Maybe if we go to the original. Nope. Okay, so I'm going to cheat and see the code. This is in input handlers. So EV key down. Well, that's interesting. Also, so we have escape actions, but we don't have move keys anymore. So it seems like they're changing something. Okay. Well, we did get the bit of info. Sorry, there's one other thing I want to double check. We did get the information which I needed, which was the existence of key. So we fixed that. Oh, we don't return any of this stuff. Yeah, so that's what my cleverness just earned me so far as that catch is concerned. I made my life much more difficult on changing it. Still learned a little bit about the pattern matching. Okay. I think we're good to run. So first of all, if I hit escape, all right, return action cannot access local variable action where it is not associated with a value. Does it initialize it as a blank? It does. The gift that keeps on giving. All right. Okay, now we don't have a character. What did I mess up now? Okay, so if I hit escape, Yeah, so no actions are happening here. And if I try to move, engine option, oh God, okay. I'm really, really blowing this. So there's still a player being mentioned here, so I can't get rid of that. I'm almost wondering if at this point it's better to just go to part 5. Okay, that matches. This is so interesting. So this... Oh dear. Okay, so under the refactoring on key down, we definitely define... Okay, actually, here's what we're going to do. Okay, so we've got action optional, action none, key event.sim. Kill that. We have a player.self engine player. We unpack move keys with key, and we perform a bump action with dx/dy. Otherwise, we perform a wait action, which is not yet defined. I'm a little suspicious about the absence of an escape action, but yeah, so escape doesn't do anything, and if I try to move, we're in trouble. Okay, let's actually deal with it. I'm going to deal with this in a slightly different way. So at line 58, it's suggesting I do underscore game map. So again, this will be under actions.py. In this case, I'm going to move back. I'm going to move backwards from our oh God, okay. Okay, 58 is self-engine game map, so that's target actor. Yep. Okay, so that was my mess up. Well, they're all my mess ups, but okay, escape still doesn't work. Okay, so I'm going to just do a search for... Is it really? Nope, that's lower than I was expecting. So if I look up... I'm sure this is just me missing the cases again, so... Okay, definitely a dispiriting little digression, but lesson learned. Now I don't remember what the VI keys were. HJK... What? HJK LYUB... How on earth? Oh, hang on. Wow. I am very glad I do not need to use this to... Is this... L to go up, okay. -10 is 8. Really? No, that's not right. Okay. K. Jesus Christ. Oh, wait, no. That makes sense. So J is down somehow. Amazing. Okay. Let me verify that this is in fact the case. H minus 1, 0, 1, 0 minus 1. Good Lord. Maybe some background for me. In my own time, I actually use Mac a lot. And one thing I really like about OS 10 is that every program, I think this is just a setting for the OS or something like that, but basically everything accepts the Emacs hotkeys. So I'm like sort of familiar with archaic conventions, but on the one that does not seem to have the same mind share as everybody else's. So like, I really do love that I could be using something like Scrivener or you know, even just writing an email or browsing a website, and I can do something like, you know, Control N or Control A, you know, to either move to a new line or to get to the beginning of a line. But and look, I'm not going to lie, there are many people who use Vim very effectively. This is going to take some getting used to, I think. All right, so that was definitely a self-inflicted, excuse me, that was definitely a self-inflicted digression, but I think we're there. Yeah, since neither side can actually die, combat doesn't feel all that high stakes just yet. What do we do when an entity reaches 0 HP or lower? Well, it should drop dead, obviously. But what should our code do to make this happen? To handle this, we will refer back to our fighter component. Remember when we created a setter for HP? It will come in handy right now, as we can utilize it to automatically kill the actor when their HP drops to 0. Add the following to fighter.py. Okay, adding our annotations. And then test for the actor. Well, test for type checking and then import actor. Okay, now check if the HP is equal. Shouldn't it be less? Right, because you've already got the max 0 min value. So self HP equals 0 and self entity AI self die, which isn't written yet. Self engine player is self entity death message else is dead. Oh, cool. It's setting a little body on the ground. Okay, that's interesting. So there's lots of things that can still wind up on the screen once you take... Well, I guess there's like a limit to the number of monsters, but you just let the bodies sort of pile up. When an actor dies, we use the die method to do several things. Print out a message indicating the death of the entity, set the entity's character to the % sign. Most roguelikes use this for corpses. Set its color to red for a bloody, gory mess. Set blocks movement to false so that the entities can walk over the corpse. Remove the AI from the entity so it will be marked as dead and won't take any more turns, and change the name to remains of entity name. Run the project now and enjoy slaughtering some orcs and trolls, or possibly being slaughtered myself. All right, that's interesting. I spawned on top of the orc. It seems like there's nothing to prevent that. Orc is dead. Haha. I feel like this is something that the tutorial would have covered already, so I should be... Ooh, I'm getting hit by both. Yeah, I should maybe take a look into the... Take a look into the tutorial to see if there's anything to confirm the bad guys don't spawn on me. Sorry, I'm absorbed by my journey through the level. It is kind of neat to see the bodies sort of sticking around. It does have a little character in the... It does add a little bit of character in the... game. Now this is interesting. So, oh, sorry. I was looking looking at the bottom of the screen. I'm like, how do I get down here? But that's part of the tutorials map. Okay. I don't think there's anything else for us to do in here. So one thing I'll want to follow up is to see whether or not there's anything to prevent the player from spawning on top of an ore. I believe there is, if I'm not mistaken, but I've been feeling a little foggy since early on in this, so I think we'll see what happens with part 7, but it might be, actually, you know what? There's one other thing I want to see. I want to see what happens when oh, hang on. Escape action is missing an entity. You'll never catch me alive. Remains of the player attacks the orc. Fun. Actually, I feel like okay, so as silly as this is, I actually feel like there might be something that you can do with this, right? So there's the idea that when you play a roguelike, right, you have this procedurally generated dungeon, and I know some games will have sort of seeded dungeons to see, like you can compare against other players and such. But there's something kind of neat with this idea of, instead of that being, okay, you didn't go through that one, you'll never see it again, or it's very unlikely that you'll see it again. I wonder if there's something that you can do about continuing on in a roguelike, right? So there's the permadeath aspect, but somehow permadeath isn't the end. That there's something maybe that your ghost can do to sort of run through. I know like I think in Terraria, there's a version of this where there's like a roguelike mode, and if your character dies, that's it. But I think you are given the option to sort of run around the level as a ghost just to see what everything kind of looked like. And I wonder if you can go one step further with that and say, okay, I've got the roguelike and it plays by the normal rules, but what I want to do here is instead of just sort of throw away a perfectly good randomly generated dungeon, we're gonna have something that says you can get either a lesser victory, or you can have some sort of an experience as someone who didn't make it through here, but you're able to kind of get to the end and see how everything works. I don't know. There might be something fun that we can do with that. Okay. If you play the game of it, you'll notice 2 problems. The first is that sometimes corpses actually cover up entities. The player is currently under the corpse in the screenshot. Okay, well, that's sort of covered. This not only makes no sense, since the entities should be walking over the corpses, but it can confuse the player rather easily. The other issue is more severe. Try playing the game and letting yourself die on purpose. Well, we already know what happened. The player does indeed turn to a corpse, but you can still move around and even attack enemies. This is because the game doesn't really end at the moment the player dies. The only thing that changes is that the player's AI component is set to none, but that isn't actually what controls the player. The event handler class does that. Let's focus on the first issue first. Solving it is pretty easy. What we'll do is assign a value to each entity, and this value will represent the order in which the entities should be rendered in. Lower values will be rendered first, and higher values will be rendered after. Therefore, if we assign a low value to a corpse, it will get drawn before an entity. If 2 things are on the same tile, whatever gets drawn last will be what the player sees. Excuse me. To create the render values, we'll create a new file called render order and put the following class into it. From enum import auto enum class render order enum auto. Presumably it just assigns 0, 1, 2 at this point. You'll need Python 3.6 or higher for the auto function to work. We already know we're on Python 3.12. Render order is an enum. An enum is a set of named values that won't change, so it's perfect for things like this. Auto assigns an incrementing integer value automatically, so we don't need to retype them if we add more values later on. To use this new enum, let's edit entity.py. And this is after typing. I should probably remember the order here just because this is something that we wrote ourselves, but all right. So to init, we go after blocks movement, render order, corpse. That's a default value here. That's not right. Right, because we're inheriting the initialization from the parent super init after blocks movement. There we go. We're now passing the render order to the entity class with the default of corpse. Notice we don't pass it to actor and instead assume that the actor's default will be the actor value. In order to actually take advantage of the rendering order, we'll need to modify the part of game map that renders the entities on to the screen. Modify the render method in game map like this. Okay, renders the map. So after console RGB, okay, so we sort, we've got the thing we're sorting, which is self.entities, and in this case we're doing a special sorting. So in this case we use lambda, which is basically, I think these are called anonymous functions. So the idea here is instead of defining sort of a simple little one-line function that we really only just need to use once, anonymous functions, lambdas, allow us to sort of define that in a very sort of minimalist way. So in this case here, we're basically saying we've got this function x, and in this case, we're applying this function x. Well, actually, the function isn't called x. The function's anonymous, but we're basically applying this function to self-entities, and in this case, sorted allows you to sort of use a special argument. It'll allow you to sort of say, give me the ordering. And in this particular case here, because we've already defined render order, this is essentially taking the those autos that we've already used, and it's sorting the list accordingly. So for entity in entity sorted for rendering. Entity X, entity Y, string, entity car, entity color. I think we're just spreading this out over a few lines. Looks like it. Well, yeah, that would make sense because we've already handled the sorting through sorted. All right. The sorted function takes two arguments, the collection to sort and the function used to sort it. By using key in sorted, we're defining a custom way to sort the self.entities which in this case, we're using a lambda function, basically a function that's limited to one line that we don't need to write a formal definition for. The lambda function itself tells sorted to sort by the value of render order, since the render order enum defines its order from 1, corpse lowest, to 3, actor highest. Corpses should be sent to the front of the sorted list. That way, when rendering, they'll get drawn first, so there is something else on top of them. They'll get overwritten, and we'll see the actor instead of the corpse. Last thing that we need to do is rewrite the render order of an entity when it dies. Go back to the fighter class and add the following. Why do I get the feeling I'm in the wrong section? There we go. Okay, from components, then we add from render order, port, render order. And in the base component, this is confusing. Self-entity AI. I feel like I've missed something here. Okay, we're importing the actor, class fighter base component, entity actor. So we've moved over some of these things, but... Oh, here we are. Okay. Sorry, not paying attention. It's in die. I should have been thinking. Render order, goals render order corpse. Cool. Run the project now, and the corpse ordering issue should be resolved. Now on to the more important issue, solving the player's death. So before we do that, okay. Away. Now there's, I guess, not going to be a situation in which I am rendered over an orc or a troll simply because they always block. I know this is a sort of a distraction, but I kind of want to see... Okay. I actually want to see what's going on with generating enemies on the player's location. Okay, so this doesn't seem to generate. All right, completely forgot there was proc gen. So this has just been bugging me ever since I saw that. So I felt like there was something that stopped enemies from, hang on, this just makes the dungeon. I don't think this actually adds the baddies. Nope, place entities. So place entities is in proc gen. Okay, place entities, it's in a rectangular room. We have a maximum number of monsters. So for I in the range of number of monsters, we put a random integer within the room, X and Y. If there is no entity in the X and Y, it doesn't get placed. So I suppose that invites the question in terms of where, I guess the player gets placed in the very first room. Okay, so we make a deep copy of the player from Entity Factory's player, place them in the engine. The engine makes a game map which generates the dungeon. Okay, so let's work with that. So we're generating the dungeon. We've got a player defined through engine player. So this is interesting. It's actually me getting in the way of the orc. So we say place the player in the new room, in the center of the new room, but it doesn't check to see if anything is there. So it's a very small chance, but clearly it's not impossible because we've seen it. So now I guess the question would be, is that something you want to worry about? Excuse me. The fact that you can't represent both entities being in the same place is sort of deceptive. I'm not entirely sure taking like one hit from an orc or a troll is really going to, like, that's really not going to move the needle. And I don't know, like, is that any worse than, say, having an orc or a troll spawning right beside you? But I can definitely see how people would be annoyed by that. So I imagine at some point, maybe we'll just double check that place doesn't have something to protect from overlapping. Okay, so X and Y, place this entity at a new location. Yeah, no, it just puts itself in the spot. Whatever else is there, can take a hike. Okay, that's interesting. I'm wondering if there are other. So I guess there's not a situation where, like, blockables, like an orc and a troll, can wind up in the same spot on top of each other. It's really just the player on top of the AI, and it didn't stop the game from working. So I'm not going to spend too much more time. This is just, it was something that bugged me, and I wanted to at least sort of let the nagging stop in the back of my head. But I don't need to pursue this any further. Okay, now on to the more important issue, solving the player's death. One thing that would be helpful right now is being able to see the player's HP. Otherwise, the player will just kind of drop dead after a while, and it'll be difficult for the player to know how close they are to death's door. Add the following line to the render function in the engine class. So we're replacing entity with actor. Under render, under console, so print x1, y47. So I think this is just telling us coordinates to place the HP information. String f HP player fighter HP. So because this is out of a bracket, we know that the slash is like an actual slash. It's telling you this is what you've got out of presumably what max HP is going to be. So yeah, self player max HP. So if we put this within the braces like this, then essentially we would have a percentage representation of our health, which would it be a percent? I guess it's a percent if you multiply it by 100, but anyways, something approximating a percentage. Which is maybe not the, I'd like it, but it's not the most informative. Pretty simple. We're printing the player's HP, current health over maximum health below the map. It's not the most attractive looking health display, that's for sure, but it should suffice for now. A better looking way to show characters' health is coming up shortly anyway in the next chapter. Notice that we also updated the type hint for the player argument in the engine's init function. The health indicator is great and all, but our player is still animated after death. There's a few ways to handle this, but we'll go with swapping out the event handler class. Why? Because what we want to do right now is to disallow the player from moving around after dying. An easy way to do that is to stop reacting to the movement key presses. By switching to a different event handler, we can do just that. What we'll want to do is actually modify our existing event handler to be a base class, and inherit from it in two new classes, main game event handler and game over event handler. Main game event handler will actually do what our current implementation of event handler does, and game over event handler will handle things when the main character meets his or her untimely demise. Open up input handlers and make the following adjustments. Okay, class event handler, we're good here. We've got init, handle events. Okay, so for that we say, hang on. Okay, I will trust the tutorial here. I'm going to do this in a slightly different way. After the fact, I realized this is what the green text was advising me of, but I was like, I don't know if I want to cut and paste all of this. Raise system exit. Okay. You can go away. And we're adding a whole new, yeah, so after action, class game over event handler, def handle events, self none, event in tcod, event wait, action is self dispatch, event, action is none, carry on with your life. Key down self event, oops. Okay, action optional, none, key event, okay. This is familiar, sim, if key in tcod event, nope, it's different now. Oh, it's still event though. Sim escape. Okay. That should... There wasn't actually, there's one thing. So first of all, it's not Kai, it's Key. Hang on a second. That doesn't give me an error, huh? I really need to get my environment properly set up. So we got rid of Eevee quit. We got rid of Eevee quit in the main game handler. Let me just take a minute to think through what that means. So we have a key down. If I press escape, I still do the escape action. Okay, yeah, so this isn't necessary. That's fine. Event handler is now the base class for our other two classes. Main game event handler. Let me just make sure that's correct. Yes. Main game event handler is almost identical to our original event handler class, except that it doesn't need to implement EV quit, as event handler takes care of that just fine. Right. I should have just looked at the parent. Game over event handler is what's really new here. It doesn't look terribly different from main game event handler, except for a few key differences. After performing its actions, it doesn't call enemy turns nor updates the FOV. It also doesn't respond to the movement keys, just escape, so that the player can still exit the game. Because we're just replacing our old implementation of event handler with main game event handler, we'll need to adjust the engine pie to use main game event handler. All right, so replace event handler, main game event handler. From input handlers, import event handler. And then under engine, when we init, we have an event handler, but that should be a main game event handler now. Lastly, we can use the game over event handler in fighter.py to ensure the player cannot move after death. So under die, if self-engine, self-entity, you died, self-engine event handler equals game over event handler self.engine. All right. And with that last change, the main character should die for real this time. You'll be unable to move or attack, but you can still exit the game as normal. If you'd like to see the code so far in its entirety, click here. We already spent some time looking at that, but let's take a look and see what we've got in the main game. All right, as expected, the actor attribute has no max HP. That's actually probably me forgetting to put fighter in. Yep. This was in engine.py. Let's try that again. Promising. Oh, they picked a nice room for me to start in. A lot of trolls in this dungeon. All right, 4 HP in a dream. Oh crap. I'm curious if there's a way that I can give the troll the slip at this point. Feels like it just keeps gaining on me. We managed to dodge the orc. I think this one's too close to evade, though. Oh, interesting. Game over, event handler not defined. Okay, cool. That should be defined. So under input handlers, did I forget to import it? No, because it wants main game event handler. Oh, that's not the one that's the problem, though. It's in Fighter Pi. Okay, yep, and I forgot to bring that in, so. Let's try that again. Okay, somewhere I typed an unintentional 4. Now, why don't you like max rooms? That doesn't make any sense. Oh, hang on. Hard mode is when you use the VI keys. My old nemesis. I don't expect to find any orcs in the hallways, but we might as well clear it out. I am very good at video games. All right. So I'm just going to try to mash into some walls and otherwise be a bit of a pain. Then we hit escape. No alerts, no warnings. I believe that is it for part 6, part 2. So lots of things to commit. Again, not the most informative commit message, but I'm going for it. And given that there's probably 15 minutes left, I'm going to say it's probably not a great idea for me to try the next part. I will take a look, but I think, especially because I've been feeling a little groggy, yeah, it actually looks like this is getting quite a bit more dense as time goes by, just judging by the, I wonder if I can, no, there's only, At least, yeah. I mean, again, I'm not going to say, oh no, I have to do more work. I mean, the more substantial it is, the more interesting the project is. But I'm probably going to need to rethink the format. I think the last one was probably a bit of an exception, but maybe I should sort of temper my expectations and say I should maybe try to get through one part per video. So I suspect that means 3 videos for this week. I'm kind of glad that I'm doing this in advance, but I think I'll leave it here, and then we will do part 7 on its own. And I will try and do that after I've had some coffee, or otherwise have just tried to address the, I think it's the weather. I don't know, but I'm definitely feeling tired. So thank you very much for watching. I'm glad that we get to kind of run around the level now. And then I think, I'm trying to remember if I had any sort of lingering questions, because we already solved the player spawning on the enemy problem. So I guess for me, it's really just more about setting up my environment, which will just be something that I do on my own time. Okay, see you in the next one.